Yeah, hey everyone. In today's video, I'll be teaching you about software testing, its approaches and types of testing, as well as how these approaches are implemented in any organization or in any workflow. So, yeah, let's get started. So, first of all, what is software testing? So, software testing is the essential process of evaluating a software product to identify defects, verify functionality, and ensure it meets its intended requirements. It is crucial for delivering reliable, high quality applications that performs as expected, enhancing user experience and preventing costly issues before they reach end users. So, what I meant by this is, in short, we can say software testing is a process of identifying defects and to verify that software actually meets all its requirements before it is released to the end users. So, that is what software testing is. Let's discuss about approaches of the testing, or what are all the approaches that we follow in any workflow. So yeah, to ensure proper testing workflow, we follow some approaches, and today we'll be talking about functional and non-functional testing approaches. So yeah, let's get started. So yeah, what are testing approaches? So testing approaches represent systematic methodologies employed to validate software quality, functionality, and performance. These structured frameworks ensure comprehensive coverage across all critical aspects of application behavior, from basic functionality to complex user scenarios. So in modern software testing divides we divide it into primary categories, which is functional testing, which verifies what the system does, like what the software actually does, and non-functional testing, which evaluates how well the system performs under various conditions. So yeah, and selecting the best appropriate testing approach depends on project requirements, timeline constraints, resource availability, and the criticality of the application being developed. Common testing approaches include manual testing, where testers execute test cases without automation, and automated testing, which uses scripts and tools like Playwright or Selenium to run tests efficiently and repeatedly. Integrating both approaches often yields the best balance of thoroughness and efficiency in quality assurance process. So yeah, let's get started. So first we'll discuss about functional testing approach. So functional testing validates that software operates according to specified requirements and business logic. This approach focuses on verifying inputs, outputs, and user interactions to ensure application behaves as expected. So what we cover under this one is, so basically you can assume it like any requirement which came to a company and they develop a software based upon that requirement. So those requirements has to be implemented, or the software should work as per those validations. So this part we cover under this functional testing, which is our first point: validation, requirement validation. And then we also include user experience. So it ensures seamless user workflow and intuitive interface interactions throughout the application. This is also we cover under functional testing. And also defect identification. So what are all defects that are found or can be found from the user, and we identify those and uh, can fix under this one. Yeah. Now key functional testing types are unit testing. So basically unit testing is nothing but the first stage of testing, where usually the developers perform this testing using their test cases in the backend only. And then we have integration testing. So in integration testing we validate interactions between integrated modules or services. So we can say let's say we have two applications and they are both linked to each other. So they comes in handy, right? So it is must to test both the application, like they are integrating properly, and both data and data posting and getting data both are working as expected. So these cases are covered under integration testing. Then we have system testing, um, evaluates the complete integrated system against specified requirements. So basically you can say we perform end-to-end workflow, end-to-end testing in this system testing. Then we have user acceptance testing, which is usually referred to as UAT. So under this one, real users validate the system if it actually meets business needs and is ready for production deployment. And then we have regression testing. So we perform regression testing to ensure that new changes haven't adversely affected existing functionality, critical for maintaining software stability during continuous development. So in uh, usually in organizations or MNCs, changes always keeps on happening, right? So it is necessary to validate like the new changes doesn't really affect the existing functionality. So for that, to ensure that, we perform regression testing. And then we have smoke testing. So it is nothing but quick verification of critical functionalities after builds or deployments, determines if deeper testing is required or not. So yeah, now we'll move to non-functional testing approaches. So non-functional testing is nothing like it usually evaluates system attributes beyond basic functionality. So under functional testing we cover all UI related things and functional validations, everything. But in here it includes performance, security, usability, reliability, throughput, and everything. So we test all these things under this non-functional testing. So here you can see we have performance characteristics where we uh, check for response time, throughput, resource utilization, and scalability, and under expected and peak loads, right? Then we have security attributes. We perform penetration testing, vulnerability testing, and everything to ensure that the end product is secured and no loophole is there. Then we have reliability factors and every each sort of testing in here, which validates for system stability, fault tolerance, and recovery capabilities. So yeah, all these things we cover under non-functional testing. Okay, so here we have few non-functional testing types, which is performance testing, load testing, stress testing, and security testing. So I'll be covering these topics in a separate video. So for now you can just remember them as measures system responsiveness and stability under workload. Then we have load testing, which validates behavior under expected user volumes. And then we have stress testing, determines breakpoints under extreme conditions. Then we have security testing, which we already discussed. Okay, yeah. So now we will be discussing about types of testing. So yeah, so first one is web application testing. So here we um, validates cross browser compatibility verifications. Then we ensure responsive design validation across different screen sizes. And then we check for web security testing like SQL injection, XSS. So all manual and automation related testing we perform under this web application testing. And then we have mobile application testing. So under this one we cover platform specific testing, like if it is working fine in Android, then it should work the same in iOS as well. Then we have device fragmentation coverage, network conditions simulation, and battery consumption. So all these types of testing we perform under mobile testing. And at last, and we have desktop application testing. So here we check if our software is actually working fine in different operating systems. If doesn't matter if it is Windows, Mac, or Linux, it should work the same. We also check validates for installation and uninstallation procedures, hardware configurations, and all sort of things. So yeah, now let's move. Okay, so now coming to specialized testing approaches, we have API testing. So under API testing, we validate application programming interface like APIs for functionality, reliability, performance, and security. It includes REST, SOAP, and GraphQL endpoints. So we check for all the data, like how the data is getting pulled and from where we are storing values and everything. And then we have database testing. So under database testing, we verifies data integrity, CRUD operations like create, update, delete, and everything, stored procedure, triggers, and database performance. Like whatever we are getting shown on the UI is actually what data is there stored in the database. So all sort of testing, we perform it under database. And then we have automation testing, or automated testing, which leverages tools and scripts to execute repetitive test cases efficiently. So let's say for an example, uh, we want to perform a testing, which you can say like every end of the month an organization wants to test its product completely. So to reduce that time and reduce the resource involvement into that process, we simply perform automation testing where we use tools like Playwright or Selenium, which automates our software, and we can test it based upon that. So these specialized approaches complement traditional testing methods, addressing specific technical requirements and enabling comprehensive quality assurance across a complex software ecosystem. So yeah, now let's move ahead. Okay, so now we have this last slide for key considerations, like how an organization utilize testing approach in their software development life cycle or in their daily workflow. So a robust testing strategy balances functional and non-functional approaches, aligning with project constraints, business objectives, and risk profiles. So, successful implementation requires careful planning, that is 100% correct, appropriate tool selection, and skilled resources. So, how we actually implement this one is we define clear objectives and success criteria for each of the software, like what is required and what should be validated during our testing. Then we prioritize testing based on risk and business impact, and then we integrate testing throughout the development life cycle, like whatever projects involved in there and how it should behave in each of them. So we all cover these scenarios. Then automate repetitive and regression test cases if it is required. So as we discussed, in an organization, if they want a certain suit which needs to be tested at every end of the month, then we can implement these regression test cases and automation repetitiveness. Then we have continuously measure and improve testing effectiveness. So this is again a mandatory step. So doesn't matter if you have a perfect regression test case, but in an organization point of view, all those scenarios and all the functionalities keeps on changing. So it is must that we update our testing approaches and measures to test those stuffs. Okay, now uh, this is it for this video, guys. So I'll be covering uh, uh, performance testing, load testing, and stress testing under a separate video. So yeah, thank you guys, thank you for exploring our channel. Please like, comment, and subscribe Coders Bash. Thank you guys.